Find the equation of the line. Passing through -8, -4, and perpendicular to y equals 1/6 x plus 3. Let's find all the forms. Point slope, slope intercept, general form. Well, luckily here, we don't have to solve it for y to put it in slope intercept form to find the slope. This one is given to us in slope intercept form. So we can see here, there is a slope of 1/6. We want perpendicular to that. So what would be the perpendicular slope? Opposite, so instead of positive, negative. Reciprocal, instead of 1/6, 6/1. 6/1 is just 6. So the perpendicular slope that we need is -6. We want to go through the point, -8, -4. That's a point. That slope, that can get us started. Here we go. Hopefully by now you've realized we've basically been doing the same problem for the last hour. And hopefully these problems are not intimidating anymore once you realize we can attack them all the same way. Find the slope we need for our line. And then y minus y1 equals m times x minus x1, point slope form. Y minus -4 or y plus 4 equals m -6 times x minus -8. X minus -8 is x plus 8. Okay? Distribute the -6. Y plus 4 equals -6x minus 48. Subtract 4 from both sides. Y equals -6x minus 52. We've already found 2 of the 3 forms. There is point slope. Here is slope intercept. And as soon as I add that 6x to the other side so that it's 6x plus y equals -52, there is our general form. In terms of vertical and horizontal, and I'll just use the most famous vertical and horizontal lines, our y-axis and our x-axis. A horizontal line and a vertical line are perpendicular. They do meet at a right angle. Any line parallel to a vertical line is a vertical line. Any line parallel to a horizontal line is a horizontal line. Therefore, anything perpendicular to a horizontal line is a vertical line. and so on and so forth. Why am I pointing this out? Well, recall if I say wanted the vertical line through -2, +4. Remember my shortcuts. To get the equation of a vertical line, ask yourself what axis it strikes. And a vertical line would strike the x-axis. So a vertical line is x equals. And if we want it through this point, what's the x? -2. So the vertical line through -2, 4 is x equals -2. If I wanted same logic, if I wanted the horizontal line through the same point, a horizontal line strikes the y-axis. Therefore, it's y equals a number. In this case, y equals 4. We can add parallel and perpendicular stuff on top of that kind of problem. So if we have something, for instance, that passes through -2, -3, and is perpendicular to the y-axis. Think about this. If we're perpendicular to the y-axis, that means we are striking the y-axis. The y-axis is a vertical line. Perpendicular to that must be a horizontal line. A horizontal line strikes the y-axis. Y is -3. Another combination of this could be so I'm just changing things parallel to the x-axis. And if we think about it, there's our x and our y. If we are parallel to the x-axis, that means we're parallel to a horizontal line. We are some other horizontal line. And I changed everything, but we ended up back in the same spot. Horizontal lines strike the y-axis. So this is also y equals -3. Maybe one more parallel to the y-axis. Well, if I am, here's the y-axis. If I'm parallel to the y-axis, I am also a vertical line. Vertical lines strike the x-axis. So x is -2. Now, the average rate of change is basically the slope formula. Recall the slope formula, m equals y2 minus y1 over x2 minus x1. And that's how we find the slope of a line between 2 points, x1, y1, and x2, y2. if we wrote these points in function form, where instead of y, it's f of x, the point x1, y1 would have x1 as the x coordinate, but the y coordinate would be f of x1. In other words, the output of the function when the input is x1. And instead of x2, y2, we would have x2, f of x2. X coordinate of x2, y coordinate, the output of the function when the input is x2. These mean exactly the same thing, these two sets of points. So another way of looking for the slope formula is f of x2 minus f of x1 over x2 minus x1, but it's still the slope. And we're going to call this the average rate of change. So what is this? What does it mean? What do we do with it? Well, we just talked about piecewise functions. And when we were doing the piecewise functions, we graphed two linear functions, two lines. Now, lines have slope, and we used the slope of those lines. But not all graphs are lines. We've seen the different shapes. Parabolas, for instance. A parabola doesn't have a slope. There's not a constant up and over, up and over, up and over the whole way through. But if we picked 2 points on the parabola and drew a line through them, that line would have a slope. And we would call the slope of that line the average rate of change from this point to that point. And we'd use the x values. So it's just the slope of the line through 2 points. And by the way, a line through 2 points is called a secant line. So secant line is just a fancy name for line through 2 points. If the line only went and touched at 1 point, it would be called a tangent line. That's an instantaneous rate of change. We're not going to get into that. We're just talking about average rates of change, the slope of a line through 2 points, the slope of a secant line. So let's hope that all my technology works here, because I do have a visual aid for once. I'm not going to rely on me drawing something out. So let's just give me 1 second. Document camera. And that's all funky because of the totally real room I'm in that's not a green screen. Let me take care of that. Okay, so what we have here is a graph of blood alcohol concentration versus time. The x-axis is number of hours. The y-axis is the blood alcohol concentration. So if we were to find, for instance, the average rate of change of blood alcohol level from x equals 0 to x equals 1. All we'd be doing is finding the slope of the line through those 2 points. So I made it a little bigger there. From x1 equals 0 to x2 equals 1, let's find the average rate of change of the blood alcohol level. So our formula is just the slope formula. But instead of y2, we're going to call it f of x2. Instead of y1, we're going to call it f of x1 over x2 minus x1. Bottom part's easy. That's 1 minus 0. That's 1. Now on the top, we would want the function outputs, the y values for each of these x's. So x2 was 1. And we can see right there, we have the point 1, 0.06. So when x is 1, the y value is 0.06. When x is 0, we have the point 0, 0. When x is 0, y is 0. So that's 0.06 over 1. From 0 to 1, the average rate of change of the blood alcohol level would be 0.06. Now that wouldn't be 6%, that would be 0.06%. And why do we know it's a percent? Because the graph tells us blood alcohol concentration, the units are percent. What does this mean? It means during the first hour, from t equals 0 to 1 hour, the blood alcohol concentration rose by an average of 0.06% per hour. Percent per hour. Y's over x's per hour. Because the top, the y coordinates were in percents, and the x coordinates along the bottom were in hours. Percent over hour is literally percent per hour. Let's do it again. Let's find the average rate of change, this time from x1 equals 1 to x2 equals 2. So f of x2 minus f of x1, which is the same as y2 minus y1, over x2 minus x1, over 2 minus 1. So this one's over 1 again. 1 what? 1 hour. On top, when x is 2, we have the point 2, 0.09. When x was 1, it's the same point as before, 1, 0.06. When we subtract, we get 0.03. And that's percent, not 3%. It's 0.03%. So the average rate of change from x1 equals 1 to x2 equals 2 is 0.03% per hour. So it's less of an increase the second hour than it was the first hour. First hour was an average of 0.06%, second hour 0.03%. And we can see that the lines are getting shallower. The slope is getting smaller. So the average rate of change percent per hour is getting shallower. It's getting smaller. Let's do one more. Let's go from x1 equals 1. Nope, sorry. x1 equals 2.5 to x2 equals 8. So these points are on our graph as well. We'll set up f of x2 minus f of x1 over x2 minus x1. x2 is 8. x1 is 2.5. That means here on the bottom we have 5.5. 8 minus 2.5. The directions on this one, by the way, say round to 3 decimal places. We might need that information since we're dividing by something that's not 1 this time. When x is 8 for x2, we have the point 8, 0.02. When x is 2.5, we have a y function output of 0.095. That top number is going to be negative. 0.02 is a smaller decimal than 0.095. I don't want to do this by hand. You don't have to either. Calculator. 0.02 minus 0.095 equals negative 0.075. Negative divided by positive is negative 0.075 divided by 5.5 is that big long monstrosity. Rounding it to 3 decimal places, 0.01, and that 3 is going to round up to a 4. So negative 0.014, and again, tops are percents, bottoms are hours. So this is negative 0.014% per hour. What does that mean? It means on average, from the 2.5 hour mark to the 8 hour mark, if you imagine the slope of the line between those 2 points, on average, we are decreasing 0.014% per hour. You're getting less drunk as time goes on after about 2.5 hours. And in that span of time, that 5.5 hours, on average, you're getting 0.014% less drunk per hour. So taken together, these 3 rules basically say parallel lines have the same slope. If 2 non-vertical lines are parallel, then they have the same slope. If 2 distinct non-vertical lines have the same slope, then they are parallel. And 2 distinct vertical lines, both with undefined slopes, are parallel. So the first 2 basically say non-vertical because vertical lines have undefined slope. 2 non-vertical parallel lines are going to have the same slope. If they're parallel, they have the same slope. If they have the same slope, they are parallel. And then the third one says, by the way, even vertical lines, both having undefined slope, are parallel. All vertical lines are parallel to all other vertical lines because they all have undefined slope. So if the slope is the same, it's parallel. Parallel lines have the same slope. I think we're ready to move on. Now we're going to go ahead and write equations of a line parallel to a given line. This example says write an equation of the line passing through -2, 5 and parallel to the line whose equation is y equals 3x plus 1. Express the equation in point-slope form and slope-intercept form. So we'll just start with point-slope form, then we'll solve for y to get slope-intercept form. Seems simple enough. We would need a point, and they give us a point, and we would need a slope. Well, they don't give us the slope by saying, here's the slope. But what they do say is that our equation needs to be parallel to y equals 3x plus 1. And what did we just go through in painstaking detail? Parallel lines have the same slope. What is the slope of the line y equals 3x plus 1? The slope of that line is 3. So our slope, being parallel, must also be 3. So we're going to set up our point-slope form. And then we're going to plug in our point and our slope of 3. Being careful when we subtract x1 to subtract the entire -2, because minus a -2 becomes a +2. So that is our point slope form. To get slope intercept form, we would have to distribute the 3 to get rid of the parentheses, and then add 5 to both sides. Y equals 3x plus 11. Oh no. More painstaking detail, this time for perpendicular lines. Taken together, these 3 statements are basically going to say that perpendicular lines have opposite reciprocal slopes. If 2 non-vertical lines are perpendicular, then the product of their slopes is -1. If the product of the 2 slopes of 2 lines is -1, then the lines are perpendicular. And a horizontal line having 0 slope is perpendicular to a vertical line having undefined slope. And that goes both ways. A vertical line is perpendicular to a horizontal line. What does perpendicular mean? It means 90 degrees, a right angle. So we're saying that these meet at right angles when the product of their slopes is -1. Well, to get a product of 1, they must be reciprocals. To get a product of -1, one has to be plus, one has to be minus. So the slopes of perpendicular lines are opposite reciprocals. Let's find the slope of any line that is perpendicular to the line whose equation is x plus 3y minus 12 equals 0. So we would want to find the slope of this line, because that's how we would find a perpendicular slope. We need a slope to start from. So let's solve for y. Subtract x, add 12. 3y equals -x plus 12. Divide both sides by 3. That divides everything by 3. Y equals -1/3 x plus 4. So the slope of the line that we were given is -1/3. The slope of a perpendicular line would have to be an opposite reciprocal. So change negative to positive and flip 1/3, +3/1 or +3. Now that we know how to find a perpendicular slope, let's write the equation of the line passing through -2, -6 and perpendicular to the line whose equation is x plus 3y minus 12 equals 0. Express the equation in general form. Well, to start this, we would need to find the perpendicular slope, and gosh, this equation looks familiar. The slope of that line is going to be 3 from the previous example. To refresh, we found that the slope of the given line was -1/3. The perpendicular line is the opposite reciprocal, or +3. So start with point slope form. Plug in our slope of 3 for m, plug in our -2, -6 for our point, being careful that we are subtracting the entire negative, because minus a negative becomes plus. So y plus 6 equals 3 times x plus 2. We want to be in general form. That means our x's and our y's have to be on the same side. Let's get rid of the parentheses first by distributing. And if we subtract 6 from both sides, we get y equals 3x. Keeping the x's positive, let's move the y to the right side. We'd have 0 equals 3x minus y, which can be written as 3x minus y equals 0. But this is general form. X's and Y's on the same side. X is positive. It's not necessarily wrong if the X's are negative. Negative 3x plus y equals 0. Also technically correct. It's just a math convention. Doesn't that sound like fun, a math convention? Woohoo. Okay, so slope can also be thought of as a rate of change. Since slope is defined as the ratio of rise to run, that's a change in y to a change in x. It describes how fast y is changing with respect to x. For a linear function, slope may be interpreted as the rate of change of the dependent variable per unit change in the independent variable. Recall that the independent variable is x. Y is the dependent variable because y is dependent on x. X is the thing that we change. X is the thing that we input into functions. Y, the function value, is the output. It's dependent on the input. You could also remember input, independent. That seems pretty straightforward. In 2000, 11.9% of young adults lived with their parents. In 2017, 22.0% of young adults lived with their parents. Use this information to find the slope of the linear function representing young adults living with their parents. Express the slope correct to 2 decimal places and describe what it represents. So the important thing is we have 2 sets of paired data. We like that. We like that we can identify that because we can form 2 ordered pairs. And from that, we can find the slope. So in 2000, it was 11.9. The input is 2000. The output is 11.9. And if we change the input to 2017, our output is 22, 22.0%. So X is the year, Y, or F of X, is the percentage of young adults living with their parents. So plugging these into the slope formula, 22.0 minus 11.9 all over 2017 minus 2000. That gives us 10.1 divided by 17, which is approximately 0.59. So the interpretation of a slope of about 0.59 is that the percentage of young adults living with parents is increasing at a rate of 0.59 per year. The rate of change is 0.59% per year. And that makes sense. If we're going up about half, a little more than 0.5% every year, over 17 years, that'll take us about 14%. Sorry, 10%. Okay, slope as an average rate of change. If we were to draw a line through this nice squiggly function, f of x, that line would hit this function in 2 points. If we were to find the slope of this line, and by the way, a line that intersects another line in 2 points is a secant line. we were to find the slope of this secant line, we would have what we call the average rate of change from the initial x value to the final x value. So the average rate of change from x1 to x2. It looks a little different, the formula does, when we're using f of x instead of y, because our y1 can be specified as the output we get when we input x1, or f of x1. Input x1, output f of x1. Input x2, output f of x2. So instead of y2 and y1, we have f of x2 minus f of x1. But we know that that's the same as y2 minus y1. This is the same as the slope formula. So let's find the average rate of change for the function f of x equals x cubed from x1 equals -2 to x2 equals 0. So the average rate of change version of the slope formula, f of x2 minus f of x1 over x2 minus x1. We have our x2 equals 0. We have our x1 equals -2. We have the function f of x equals x cubed. So we have to plug these x values into the function to get the output. F of x2 taking 0, plugging it in for x cubed. 0 cubed is 0. F of x1 taking -2, plugging it into x cubed, we get -8. So we get 0 minus -8 over 0 minus 2. Zero minus -2, excuse me. 0 minus -8 is 0 plus 8, which is 8. 0 minus -2 is 0 plus 2, which is +2. We get 8 over 2, which is 4. So the average rate of change from x1 to x2 for this function is 4. And that's it for this topic. I want to talk about something called a piecewise defined function. And the key word here is piecewise. It's a function that's defined in pieces. It's cobbled together like a Frankenstein function. A little bit of this, a little bit of that. So you might have seen me previously draw things like this. If this is the graph, maybe something like that. And while this couldn't be one thing, between here and here, this is a piece of some larger line. And then between here and here, that's a piece of some larger line. And between here and here, that's a piece of some larger line. And between here and here, and then there through there, it's this side of that line. So if we cobbled together these 1, 2, 3, 4, 5 things and put restrictions on the x values we were looking at, we could get this function written in numbers and letters. So imagine this was our function, f of x equals, and then this is not a face. It looks like a face. Hello. For someone who can't draw, that's a pretty nice face. There we go. Not what I was drawing. We're doing math. We're not drawing. That's a left brace. It's not going to have a right brace. So this is all this big symbol here, this left brace, like we would see on a set, just the left one, is going to group together a bunch of different functions, different conditions. This will be the function we're going to look at. We have three functions put together. F of x equals negative x minus 1. F of x equals negative 3. F of x equals the square root of x minus 2. But remember, just like that one I drew, between different values of x, we'll have one of these different pieces. So the function is equal to negative x minus 1 for all x less than negative 1. And the function is equal to negative 3 for all x between negative 1 and 2, equal to negative 1, but not equal to 2. And f of x equals the square root of x minus 2 for x greater than or equal to 2. So my first question for you is, what is f of negative 3? Well, normally to find f of negative 3, we plug negative 3 into the function. But which one do we plug it into? Well, we look at the rule. F of negative 3 means x. Means, there we go. Means x is negative 3. Well, negative 3 isn't greater than or equal to 2. Negative 3 isn't between negative 1 and 2. Negative 3 is less than negative 1. That means for f of negative 3, we put it in this one. Instead of negative x minus 1, we have negative 3 minus 1. Two negative signs, because we are replacing the x with the entire negative 3. When I write this out, when I plug things in, I like to just replace my x's with parentheses first to make sure that I get the right number of outside minuses. And then I plug my -3 in afterwards. And then I evaluate. The opposite of -3 is +3. 3 minus 1 is 2. So f of -3 in this piecewise defined function would be +2. Same function. This time, f of -1. Well, we can rule out the third one right away. -1 is not greater than or equal to 2. But are we going to use the first one again, or are we going to use the second one? Well, -1 is not less than itself. So we would have to look for the or equal to here. So if x is equal to -1, like here, it's going to fall on the second one. And for all x values here, including this one, the function is equal to -3. Nothing else to do there. It's just equal to -3. Next up, let's look at f of 2. 2 is greater than or equal to 2. So I'm plugging in 2 minus 2 under the radical, which is the square root of 0, which is 0. So f of 2 is 0. Finally, for this function, let's take a look at f of 6. Where does this fall? 6 is greater than or equal to 2. So it's the radical again. Radical 6 minus 2 is radical 4. And since we're just evaluating the symbol, that is the positive version only. F of 6 is 2. Graphing one of these should be something that we are comfortable with. Let's take a look at the following. F of x equals f of x equals, this is negative 3x for x less than 1, and just -3 for x greater than or equal to 1. The first step in graphing a piecewise function is going to be to look at where we're splitting our x values. So here, at x equals 1, we would draw a dotted line, vertical, straight through the x value. Now to the left, we'll have one graph. To the right, we'll have the other. But we get two pieces of information from this dotted line itself. That information is going to come from these two lines. The one that has the or equal to, that's going to be our filled in circle. It's going to include that point. The one that's just less than or greater than, that's going to be our open circle. To figure out where we're going to put our open circle, our closed circle, our filled in point, our open point, we're going to plug the x value in. Yes, I know this is the one that says equal, but we're still going to do both. The one that says equal is going to be the filled in one. That is where the graph will exist there. But we still need to know where the open circle is. That's why we plug it in here as well. So if we plug in 1 to the first one, the open circle, if we plug 1 in, -3 times +1 is -3. So we will have our open circle on the x value of 1 at -3. If I go to the second one, well, my filled in circle is also at -3 because for all x values greater than or equal to 1, I'm at -3. So I get to fill in my open circle. It's the same point. That means this graph's going to be continuous. It's not going to jump to another point to continue off. And actually, for all x greater than 1, so for 2, 3, 4, 5, 6, this graph is just f of x equals -3, y equals -3. Why do we need to know how to graph lines? Well, part of this is knowing how to graph lines. We did this in the last unit. So what about this side of the dotted line? Well, over on this side, we're going to have y equals -3x. Y equals mx plus b. We know how to graph that. So this is like y equals -3x plus 0. That means the y-intercept is 0. The y-intercept's on this side of the line, this side of the graph, the side we need. That's fantastic. Otherwise, we couldn't just plot the y-intercept. We would have to use the slope to count off another point. What would the slope have been? The slope is -3, which is -3 over 1, or 3 over -1. Remember how I kept pointing out two different ways to do that? Why? Well, this would be down and right. But from this point, down and right, we don't want that side of the line. We want it on the other side. So we have to know that we could also go up 3, left 1 to get our next point. So either way, from the y-intercept, if it's on the right side, or from the slope, we get our second point. And we draw our graph off. So this is that graph. What's that? You want one more? Okay, happy to oblige. Let's do one more. This time I'm going to graph f of x equals x plus 3 for x less than -1, x squared for -1 less than or equal to x less than 2. Okay, where are we splitting? Where are we splitting our x values? -1, +2. -1, +2. -1, we're going to have an open circle and a closed circle because we have just a straight less than -1. We also have an or equal to. 2, we're going to have an open circle because we have a less than 2, but we don't have another one with 2. So here we'll have an open and a closed. Here, we're just going to have an open, just an open for 2. -1, we'll have an open and a closed. Let's find these values. So for -1, let's do the open first. That's here. -1 plugged into x plus 3 would be -1 plus 3 would be +2. So on this x -1 at +2, there is an open circle. For the filled in circle at -1, we would go here. -1 squared is +1. So there would be a filled in circle at 1. Over here at 2, for the open circle, we would plug in 2 squared is 4, 3, 4. It's an open circle up there. Now in between is fun. We're going to connect from the closed circle of 1 to the open circle at 2. And the graph is x squared. We know this graph. Point at 0, 0 because it's not moved up, down, left, right any. It would connect where it's equal to -1 over here. And when we're equal on the -1 for the x, that was at 1. Over here on the right, it's going to connect at 2 to an open circle. And that was at 2, 4. We have nothing at all off to the right. Off to the left, off the open circle, we have a graph y equals x plus 3. The y-intercept would be 3, 1, 2, 3, but it's in the wrong part. This x plus 3 has to be the graph over here on the left, so we can't use the y-intercept. But it has a slope of 1, which is up 1, right 1, wrong direction, or down 1, left 1. So this graph here would be this piecewise function.